Let's say you find yourself wanting to make a reusable trigger object that does something when the player touches it. Instead of coding the behavior right in the trigger object itself, you could create a variable that holds a script or function, and then run it with script execute. This is what's called a callback, and there's many ways to implement them. The simplest one being one that takes a single function. But maybe you want the possibility of adding multiple functions to it. Maybe you want the object that owns the callback to pass its own arguments, or maybe you even want the ability to pass your own arguments to it. If you were to take this approach to adding callbacks to your project, you'd have to write this code every time you'd want to add callbacks to an object. And it's not like you can easily put this code in a function either. After all, the variable names holding the callbacks might be different every time. And what about the instance that is trying to pass the function to the other instance that has the callback? It would have to know the details of the implementation each time. As I was scratching my head trying to figure out how to implement this feature, I thought back to my Godot days. There's this thing called a signal. It's a feature that is baked right into the engine that works just like callbacks, but without you having to write the code that actually does the heavy lifting. This was nice. I wanted this. But there was just no way I could recreate this feature on my own, right? After all, the Godot team consists exclusively of godlike programmers that know what they're doing. I looked into it for a bit. Turns out it just takes about 30 lines of GML to get the basics down. I've been working on this dungeon crawler kind of game, and I've added an inventory UI component. I want you to be able to select an item from this list, and from there I wanted to bring up a window that asks you what you want to do with the item that you selected. I can make the window visible like so in code. And then you can see it appear on the screen here, but of course without any of the functionality. I could go into the UI components code and go into the if statement that checks for input. And then in there, I could just write the behavior for opening the window, but that would lead to very brittle code that would break at a moment's notice. I could create a callback here, like I discussed at the beginning of the video, but that would lead to the problems with the multiple implementations. So instead, I'm going to define a signal that is going to be emitted from here. I'm going to implement signals kind of like they work in Godot. Then I will add a signal called something like item selected to this UI instance. And then I will emit the signal from the step event when it selects an item. To emit a signal just refers to Godot terminology for calling the callbacks that have registered to the signal. Essentially, the instance will be like, I don't know if anyone cares, but the player has just attempted to select an item. The master UI object that controls the visibility of all the UI instances and decides which ones get to receive input will then run code that will handle that scenario. First, I'll create a set of macros that are going to be our variable names. I want to be able to add signals to any object, so I'll be using the variable instance functions to add variables to any instance that needs the signals. Then I will create the function that creates the DS maps that will hold the signal information in the instance. And the function that gets rid of those again. After all, data structures need to be freed so that they don't cause a memory leak. It is worth noting that I'll be making heavy use of variable instance set and get in my implementation. I'll drop a link to the documentation to that in the description below in case you want to read up on it. Now that I have these functions, I can go into my UI component and I call signal init with the ID parameter. I'll set a breakpoint and debug. And then, now that we're past that function call, we can see that there have been some DS maps added under these weird variable names. Additionally, I'll add the cleanup function to the cleanup event. The signal data now looks like this. It's just two DS maps inside of an instance. For the function that adds a signal to an instance, I'll add two lists to our maps. With this function in place, I can go into the UI component once again and add the signal called selected. This will be the signal we connect to in order to tell whether an item has been selected in the inventory. If I now again debug, we should be able to see that the DS maps now have a DS list each under the key selected. So our data structure looks like this. Now, in order to connect to the newly added signal, we'll need to add a function and its arguments to these maps containing the lists. So let's do that with a function called signal connect. With this function in place, I'll be able to add my callbacks and the arguments to those callbacks to my selected signal in the UI master object by going in here and calling signal connect past the inventory selected signal name. I'll add the function that is supposed to get called, and for all it should really do is just say hi. Yeah, that's good enough. In the debugger, I now expect to see a map containing a list containing an empty array and a map containing a list containing a function, which is the function we passed right here. However, on its own, this function right here will still never trigger because this selected signal is not being emitted. In order for that to happen, we'll have to create a signal emit function. All the signal emit function is going to do is it's going to take the lists that pertain to a signal name, and it's going to loop over the contents and call the functions with the callbacks. Now that I've established a way to actually call the callbacks passed to the signal, I can go back to my UI component and call signal emit with passing itself as the first argument and selected the signal name that we have created as the second argument. And if I now open the inventory and press select, I'm gonna be seeing hi in the console, and that's because it has actually gone ahead and called the function that I defined up here. Nice. Now that the signal has been implemented and is working properly, I can write the code to hide and unhide the desired UI components as I please. And that's pretty much it. Now you should absolutely add some error checking to the code since it doesn't throw any errors at compile time. And it's pretty likely that you'll call some of the signal functions when you don't intend to. Once you've done that, you're in a pretty solid position to start adding other functionality to the pattern as you need it. Maybe you'd like the ability to disconnect from a signal after you've connected to it. In which case you'd have to add some sort of tracking for which instance connected to which signal. Or maybe you'd like the ability to pass arguments from the instance owning the signal, so that the connecting instance needs to pass a function with a specific signature. And maybe you could even do some sort of checking that a function with the right number of arguments has been passed. As far as I know though, there's currently no way to do that, unless you're clever like Yal probably. In order to optimize the pattern a bit more, you could also add pooling for the lists and maps that get created when you initialize the signals. But in my current project, I don't really have any of these features added to my signal pattern, as I don't really need it. This simple implementation on its own is already doing plenty of work for me. So if you want to try out the signals as I implemented them here, you can find the script in the description below. Feel free to download it and just drop it into your project. It should work right out of the box if you're using a modern version of GameMaker. I'll also have a version of the script that works in older versions, so you can play around with signals in GM 8.2 if you're freaky like that. Since this is my first proper video, I haven't really thought of an outro, so instead I'm just gonna